Okay, so just like we can multiply terms together that are trigonometric expressions, you can also factor trigonometric expressions the same way we would factor things with x's and other variables. And what I'm going to do in this example is first I'm going to change all these sine functions in this red example here. I'm going to change all those sine functions to x's. And I think that will make this simpler to look at. It'll certainly make it quicker to write, and there's value in that too. So I've got negative 2x squared minus 2x plus 40. And just remember, I'm saying x is sine phi. Okay, so at the end, we probably have to undo this and put it back in terms of psi to get the correct answer. Now, when I look at this, I see it's really not that hard to factor. I pull out a negative 2, GCF, right? I get x squared plus x minus 20. So that's going to be, well, what do we get here? I think 5 and 4 are interesting, so that has to be, yeah, an x plus 5, x minus 4. Those multiply to negative 20, and they add up to 1, which is that linear term in the middle, the 1x. And now I'm done. I just need to turn it back into signs. So this would be negative 2 times sine of phi plus 5 times sine of phi minus 4. Okay? This is a technique called U substitution. I mean, I used the letter X, but we can use U in the next one. And U substitution is basically the way we say in mathematics, the factoring looks difficult. I'm going to just change this thing to U so I can think through it easier. So in this example, I'm going to let's use U. 2u squared plus 16u plus 30. Okay, same as the last one. Factor out a GCF of 2. And I get u squared plus 8u plus 15. Well, what multiplies to 15 but adds to 8? It's going to be 5 and 3. So that's 2 times u plus 5 times u plus 3. Okay, factoring is done. At this point, I just need to remember, I wasn't really doing u this whole time. I was doing sine, oh wait, no, this one was cosine of phi. So this is really 2 times cosine of phi plus 5 times cosine of phi plus 3. Okay, let's move on to the last one. It's kind of a beastie. What do we got here? I see another GCF. Okay, that's nice. Whoever programmed this problem was being generous. Plus 6. It was me. I programmed this problem. I don't really want to deal with giant factoring jobs either. This one's hard enough on its own. Look at what we... Oh, okay, so I didn't do a U substitution. I pulled out the GCF first. Now, of course, U substitution is not necessary. You can just factor it like it is here. But I find it useful to think in terms of simple letters like x and y, and not, I don't know why I changed my color, and not sines and cosines. So let's just go ahead and turn this to 5 times x squared plus 6 times xy plus 8 times y squared. And you can see what I'm doing here. I'm saying, hey, let's pull a sneaky, and x equals sine phi and y equals cosine phi. And now I can factor this one. If those variables are giving you trouble, just pretend the y's aren't there. Okay? Just imagine they're the number 1 or something. And if you did that, you would say, oh, this is just x plus, what adds to 6 but multiplies to 4? I think 4 and 2, right? So it's x plus 4 and x plus 2, right? And then we say, oh, wait, we pretended y wasn't there. It really is. So it's x plus 2y, and over here it was a 4y. And if you look at how that multiplies back out, you'll see we got this thing. Again, when you double check your factoring, which you should still always do. It's still a good piece of advice. So now we undo that substitution. And we say, okay, x is sine. So this is 5 times sine phi plus 4 cosine phi times sine phi plus 2 cosine of phi. And if you double check the factoring on this one right here, you'll see we end up right back with the original, this guy right here.